This is a video on C2 Edexcel Chemistry, Quantitative Chemistry, which is topic 6. So this is all the maths that's involved in chemistry. Remember, this can come up anywhere within the unit in any question, so it's one of the key areas. It is quite difficult, some of the maths involved in this. There are plenty of videos on YouTube that go through each one of these in detail, so remember, this is the brief overview. If you feel that there's one that you need to look at in more detail, feel free to find another video on the internet to go through it. I've been through empirical formula on a video on my channel in a bit of detail, so feel free to have a look at those. So relative formula mass, okay, this is pretty straightforward. So we can use the relative atomic masses of various elements to calculate the relative formula mass of a chemical compound. So this is true when compounds are made of molecules or collections of ions. So for example, let's have a look at sodium chloride. We know that the relative atomic mass of sodium is 23 and chlorine is 35.5. So the formula mass, the relative formula mass, is just those two numbers added together. 58.5 is just as easy work with multiples of atoms. So if you have two hydrogen atoms and one oxygen, so H2O, apologies for the mistake there, then you do 2 times 1 because hydrogen is 1, plus 16 because oxygen is 16, and that makes the new mass of 18. So relative formula mass you should all be able to do, pretty straightforward. Empirical formula is a bit trickier. So if you're given the percentage formula of an element in a compound, we can work backwards to find the ratio between the atoms in the compound. We call this ratio the empirical formula. So the ratio that we actually have is what we call the empirical formula. And it's the simplest form of ratio between atoms. So let's have a actual look at the example for this. So for carbon dioxide, it has the empirical formula CO2, which states there are 2 oxygens for every 1 carbon. So it's a 2-to-1 relationship between oxygen and carbon. Now the number is usually not the same as the actual number of atoms in a molecule, which is what we call the molecular formula, but not also it usually is the same, which is known as a molecular formula, but it's not always. It's not always going to be 1 to 2. The formula for something could be C2H4, but that isn't the simplest form. The simplest form would be a 1 to 2 relationship, therefore CH2. For example, there's another one. Water has an empirical formula H2O, which is also its molecular formula, but hydrogen peroxide has the empirical formula HO, but has a molecular formula H2O2. So you can see how the molecular formula is different to the empirical formula. So it's very similar to what I was just discussing there with C2H4. We could work out the empirical formula from a compound formed when 9 grams of aluminium reacts with 35.5 grams of chlorine. Okay, we start by dividing the mass of each element involved by its relative atomic mass. So 9 grams of aluminium, relative atomic mass of aluminium is 27, so 9 divided by 27, that leaves to 1 over 3. Now we call this number that we're making how many moles we have. Okay, so now we have 1 mole of aluminium atoms. We've got 35.5, so 1/3 mole of aluminium atoms. With 35.5 grams of chlorine, so 35.5 divided by 35.5, because that's the that's the relative atomic mass of chlorine. So 35.5 grams from here, and 35.5 is the relative atomic mass of chlorine. So that's 1 mole of chlorine atoms we have. So we know that the relationship between aluminium and chlorine must be 3 chlorines to 1 aluminium, because that's 1/3. So if you times that by 3, you get to 1. Therefore, you need to times this by 3 to get to 3. So 1 to 3, 1 aluminium to 3 chlorine. So therefore, you end up with the formula AlCl3. Percentage composition. Again, this is pretty straightforward. It's just figuring out percentages. So what we're doing here is we're using the relative mass of an element and the relative formula of a compound. You can find out the percentage of a certain element in the compound. So an example is if we're looking at the amount of carbon in carbon dioxide. So the relative atomic mass of carbon is 12. We know that there's 2 oxygen atoms for every carbon, so we need to know the relative atomic masses. The relative atomic mass of 1 oxygen is 16, and the relative atomic mass of carbon is 12, as I just said. So CO2 is going to have 12 and 2 16s because there's 2 oxygens. So 2 16s add 12. Okay, so that's 32 and 44. Cool. They asked for how much carbon there is. So you do that as a fraction of the whole. So 44 is of carbon dioxide. The 12 is just the carbon. So that's 12 divided by 44. The carbon divided by the whole carbon dioxide. So that's 0.27. Times it by 100 to get it as a percent. That's 27%. Let's have a go at another one. The mass of hydrogen in methane. So hydrogen has the relative atomic mass of 1. Carbon has a relative atomic mass of 12. It's 4 hydrogens. That's 16 altogether for this one. The CH4 is 16. The hydrogen is 4. So you need to do 4 divided by 16. So that's 0.25, which gives you 25%. That's percentage composition. Using equations, okay? So this is talking about balancing equations. Now, the C1 2016 paper is just gone, and I gave a rule to one of my students, to a whole year group of students, when I said very openly that if you're ever confused, if you're ever stuck, and those are my qualifiers, if you're ever confused and you're ever stuck about balancing equations, just put a 2 in front. It usually helps out. It's not always going to be 2, but giving a 2 might help. So remember, if you're balancing equations as part of this, make sure you can balance them correctly. Look for how much there is on both sides of each atom to get them balanced correctly. So it should all be fairly well rehearsed. It's not always 2, but more often than not it has been. So if you have a balanced equation for a reaction, you can calculate the masses of reactants and products. Okay, so let's have a look at this. We've got a sample question here. So look at this equation. CaCO3, many of you will know that as calcium carbonate, makes CaO, calcium oxide, and CO2, carbon dioxide. So you have 50 grams of CaCO3. How much CaO can we make? So first you work out the relative atomic masses of the two compounds. So CaCO3 is 40 for calcium, 12 for carbon, and 3 16s because we have 3 oxygens, so that's 100. So this one is 100. The relative formula mass for calcium oxide, well, that's 40 for calcium and 16 for carbon, so it's 56. So this means if you have for every 100 grams of calcium oxide you put in, for every 100 grams of calcium carbonate you put in, you get 56 grams of calcium oxide. So, what do you need to do? If you're told you only have 50 grams, well, for every 100 you get 56. Therefore, for every 50 you get 28. Okay. Notice that in this, 22 grams of carbon dioxide will also be produced, because that's 50 minus that 28 to give you 22. Right, percentage yield. So this is about when we've got a calculation taking place, an experiment taking place, and you're trying to figure out how much product you're producing, and therefore you theoretically calculate it. But remember, in practice, this is never going to happen. You're never going to get exactly the amount you theoretically say you're going to produce. So we've all decided the percentage yield. So sometimes some reversible reactions might not always go to completion. Some products might be lost when it's removed from a reaction mixture, and some reactants may react in an unexpected way. So you might get some leakages and some other ideas like that. So the yield of reaction is the actual mass being obtained. The percentage yield can be calculated from. Percentage yield is the actual mass of the product divided by the maximum theoretical yield of the product. That's what you think you're actually going to get, say, from using the equations above. So say, we think we're going to get 28 grams of calcium oxide, but you only end up with 24. So that's 24 is the actual mass, 28 was the theoretical, and then you times that by 100. So here's another example. So the maximum theoretical mass for a product for a certain reaction is 20 grams, but only 15 grams is obtained. So the 15 divided by 20 times by 100 is 75%. The maximum theoretical mass of the product itself can be calculated from using a reacting mass equation, such as the one on the previous page. Well, it's in the previous page, but it's just up here. They're the ones up here. The other idea is that actually you might end up with more mass than you actually expect. So what could have happened there is you've probably picked up some of the other materials involved in the reaction. To say it's an electrolysis reaction or something along those sort of lines, you haven't washed everything off that you should have, or you haven't allowed something to dry out, and therefore there could be some sort of solution left behind. And that's the end of C2 Edexcel chemistry. Good luck with the examination.